ICANN's the result of the internet community coming together and saying we need to organise how we run the internet. And so it consists of the various components that make the internet work, including, for example, the managers of the country codes, the .nz, .us, .gb. All those country code managers got together and said we need to organise how we work together. Same with the registries that run the top-level generic domain names like .com. All the registry managers come together and work out how to run the registries. Accessing those registries are registrars who sell to individual consumers. They get together and organise themselves. So all the different components have come together. Governments from all around the world have a place, and all together we make up ICANN. It's the body that manages the resources of the internet. Yes, well, the most interesting one at the moment for us is how to change the appearance of domain names from just using English script. At the moment, that's all that's been able to be used because of technical reasons, but we've been working very hard for about 2 years, and we can now insert foreign non-English scripts. So people from use Arabic or Chinese or other characters are now going to be able to have their own domain names using their own scripts, which we think will add enormously to the appeal to those people and improve their access to the internet. It is more complicated, and to make sure that it's going to work, as I say, it's taken us about 2 years to solve the technical difficulties, and we are running at the moment trials of 11 different new scripts to make sure that we get that right. But once the trials are finished, we think the system will be able to roll out and cope without any problems. My definition, it includes obviously names, the domain names that we talked about, the country code domain names and the top-level generic domain names. The management of those is part of the system. The other portion are the addresses. You have to have an address so that the system knows where you are on the internet. That's like the equivalent of your telephone number in a very rough analogy to the telephone system. Another one is the routing tables. The system has to know how to find you, and the systems that the ISPs operate to send traffic around the internet. All those are critical internet resources. Well, because if there's something goes wrong with any one of those, we lose the key principle of the internet, which is this end-to-end principle. The idea of the internet is that any person connected to the internet is in communication with every other person on the internet. A message can go from one place to another, from the end to the end. And if something goes wrong with those domain names or something goes wrong with those addresses, then that end-to-end principle breaks down. Well, the greatest hope is that we're going to continue growing and adding more people. We've got about 1.2 billion people accessing the internet at the moment. Clearly there are many people in the world yet to connect, so the hope is that we'll be able to connect up everybody and the devices that they use. That includes more and more mobile devices. So greater connectivity, greater use is the hope. The fear is that one of those infrastructural resources will prove difficult or limiting. And we're seeing that at the moment with a change in the address space. We've had a system called version 4 for the addresses that I mentioned, and we're shifting now to a version 6 because we're actually going to eventually, in about 2010 or 11, have used up all of the version 4 addresses. Not a problem, not a fear necessarily, but just one of the challenges that we face technically. Well, there isn't a centre of gravity for the internet, and part of the principle of ICANN and many of us who've been involved in other organisations is to make sure that no one person or no one company or no one country or no organisation is going to actually control the internet. The benefit of the internet is that it's distributed, and most of the power occurs at the edges. Any single person can join up, create their own software, make their own systems and do what they like on the edges. And that's the reason really for the phenomenal success and uptake of the internet. It has not been controlled and means that people can use it and develop it in ways that suit them. Governance is the system of making rules and making sure things work. And at the moment, that's a system which involves governments in an advisory capacity. The kind of rules that we make at ICANN that deal with how names and addresses are going to be used, created, allocated, etc., involves governments in an advisory capacity. So the governance is done by this bottom-up, industry-led. All the communities that actually use the internet have a role in governing the way the system works. Governments are another player, and they have a crucial role in ICANN in terms of the Government Advisory Committee. So governments are fitted into the governance structure very, very nicely. The biggest current threat is deliberate actions by malicious people who want to try and bring the system down for reasons that we don't understand. They have the ability to harness computers on the system to send message after message after message to a particular place, which in the end results in a denial of service. The system actually breaks down under the enormous load that can be created. That's the current biggest threat that the internet faces, is these denial of service attacks that can be launched from one country to occur in another country, and in the end could have severe consequences for a major registry or a major customer using the internet. Well, ICANN works closely in partnership with a number of organisations that have security as a particular focus. There is a lot of outreach to make sure that there's people who can do something about that. It's difficult for the average consumer to do much about that. One of the ways of dealing with it is to require manufacturers to change some of the specifications on the computers before they send them out. Otherwise they are able to be captured without people realising it and used in one of these denial of service attacks. So there's a whole raft of things that are being done at the moment to try and meet this particular threat.